right, hopefully we found out that from the setting up the circuits, that circuit B is more useful because we can get our minimum potential difference here is 0, and our maximum potential difference is the maximum potential difference of the supply. So if we wanted to draw a current potential difference graph for any, actually any component, let's do the bulb. Why not? Since we're using the bulb in these circuits. If we're interested in this bit of the graph, right, with this circuit, we can't get any data, really meaningful data around the origin. Right? It's very difficult to do that. Whereas with this circuit, we can. Yeah, of course we can. We can get great data anywhere on the line. This is mostly useful for the diode. The diode, I don't know if you remember from GCSE, when we do that experiment, has got conducts electricity here, and you get no current here. And this point here is called the threshold voltage, and it's not quite at 0. So if we want to measure that, we're going to need this circuit. We can't cope with this circuit, it's not going to work. So we're going to be using this type of circuit. This type of circuit is called a potential divider, and I'm just going to quickly explain how you can think about the way that it works, because you might look at it and think, what on earth is going on? How can this work? In the circuit we are now using for our current potential difference characteristic graphs, we've got I'm going to draw this nice and big, a variable resistor. We just short circuit the power supply with the resistor, right? And then it's a variable resistor, and so we can tap off for our component here from there. Okay. Now this is a 10 volt power supply, let's say, just because it's what we used in the last experiment. That means that as the charges go round, each coulomb of charge, so that's quite a lot of electrons, it's 6.25 billion electrons, but each coulomb of charge will receive 10 joules of energy. Right? This is a way of thinking about it. It's not exactly what's going on, because this is kind of a model, and this breaks down in other areas, but just for this, each coulomb of charge receives 10 joules. So you've got your coulomb of charge, and actually let's go conventional current, let's go positive to negative. So you've got your coulomb of charge coming around here. And when it gets to here, because these leads have got no resistance, it's still got 10 joules, right? So the potential here is 10 volts. I could just say there's nothing in between this. We've got 10 volts here. But when we come back to the power supply, actually we've got 0 volts left. So I'm just going to split this up actually at the power supply. I mean, perhaps I should have done that at the beginning, but it makes sense, I think, to go round the loop of the circuit. So your charge is coulombs of charge, no energy, battery gives them energy. They don't lose any energy in the wires, that's an assumption that we make. Still got 10, each coulomb of charge has still got 10 joules, so we've got 10 volts over here. And over this side, actually, well, they're not losing any energy in this wire either, so actually they've got 0 volts over here. And just because that's where I've drawn the junction, and I could have drawn the junction here, but just because of that, I'm also going to write the potential here. The potential here is 0 volts as well. Right. Now, in the resistor, it's just a wire-wound resistor. So inside here, we're just going from 0 volts to 10 volts. And so let's say some place in the middle, we should have 5 volts, right? These coulombs of charge, they should have used 5 joules of energy battling to get through this wire. They've got 5 joules left. Right, so if I were to measure it here, I get a potential of 5 volts. If I measure it here, maybe I get a potential of 2 volts, because they've used 2 joules. They've used 8 joules battling through the wire. I've gone the wrong way in the last one, but it was half and half, so it doesn't matter. 8 joules battling through the wire. They've got 2 joules left, so the potential's 2 here. Right, if I've got the point here. Maybe they've used 2 joules battling through this wire. They've got 8 joules left. If I measure the potential here, it'll be 8 joules. And so here I've got a kind of sliding scale. It's continuous scale. I've got every number in between 0 and 10 along this wire wound resistor. And when I tap it off with this slider here, I can actually just select whichever voltage I like. So let's say I'm here in the middle, get my 5 volts potential from here, and if I connect that up to the 10 volt potential this side, I've got a potential difference of 10 volts. And actually, if I connect it up to the 0 volt potential this side, I've got a potential difference of 5 volts. Did I say 5 volts last time? I meant to say 5 volts. So between 10 and 5, potential difference 5 volts. Between 5 and 0, potential difference 5 volts. Slide the slider to here. So between 10 and 2, we decided this was potential difference 8 volts. Between 2 and 0, potential difference 2 volts. So the way I've done this circuit is that I'm going between 0 and whatever value I've got on my slider. And so I can get any value between 0 and 10 volts here. If I slide this all the way up to here, then actually I'm getting potential of 10 here, I've got potential of 0 here, potential difference 10 volts. So I can get any value between 0 and my supply voltage, which in this case is 10. Hopefully that makes sense to you. This is a kind of a version of a potential divider circuit, and a potential divider is a specific type of circuit, and there are some potential divider circuits with fixed resistors. If you Google it, you're actually probably more likely to see circuits with fixed resistors. We're going to cover those, I mean they're in the booklet, we're going to cover those in later lessons, but we need this circuit in order to get decent current potential difference graphs for our components. Okay, so hopefully you managed to set up the circuits, hopefully it all makes sense, but if it doesn't, if you've got any problems, then please post on the team or email me. Manuel, you're just going to have to watch the videos and imagine that you're doing the experiment. I'm sorry, because Manuel hasn't got a full set of equipment, but everybody else should do. So hope we're all okay, and if you've got any problems with any of this, let me know. When it gets more complicated, I'm going to start doing live lessons potentially, but at the moment I actually think it's more beneficial for me to film it. I can film it, you can watch it, and then you can go somewhere else and do it, rather than having to have the Microsoft Teams thing open with in front of the experiment, and then I'm going to watch you set up a circuit. It's it could be a bit of a mess, that. So I mean, if you disagree and you prefer me to do some live stuff, then by all means let me know. But I'm planning on doing some live stuff, but not when we're doing practicals like this in lesson. So anyway, thanks everyone, bye.